What I want you guys to do to start this lesson is see if you can hit that bullseye on the wall.
What bullseye?
Well, the green one, the one right in front of you.
Your bullseye.
Oh, that was so close. They have to adjust in them trying to hit the bullseye.
Angle.
The angle, right? Okay, so what we figured was that they have to figure out what's the correct angle for them to hit the target. Okay, and so if you can imagine, they were actually just creating the hypotenuse, trying to get to the hypotenuse of a triangle. One real life problem I like to do, especially because these look like little rockets, I'll say, like, let's say this is an airplane, and an airplane is taking off. In Los Angeles, you got buildings everywhere. When planes take off, they got to take off high enough at an angle steep enough so they don't go crashing into some buildings. And in New York, so if this plane is taking off, you've got to clear that building, or if there's a mountain there, they got to clear that mountain and get over it. So that's another real life problem that I like to use in my classroom. So to start off, we'll just start off with trigonometry. What is trigonometry? What does it mean?
Okay, real quick, in the book it actually breaks it down for us. Trigon meaning triangle, and actually if you break it further down, in case you kids, are wanting to decode words, tri means 3, and gon is angle. Metron meaning measure. So knowing the background of words, and this is actually a Greek word, it really helps you in case you are unfamiliar with words on tests or anything like that. In a right triangle, it's the ratio of the side opposite a given acute angle to the hypotenuse. Yeah, I'm just going over the definitions. They'll actually go over it to all the language.
Sine, this is how you write it, but we like to shorten up anything we can in math. So instead of writing the E, we're going to take out the E and say sine, but not sin. It's not sin, it's sine. So, okay, so everybody say it with me. Sine. Okay, not sin, say sine.
Sine.
Sine. Okay, so sine of A is the measure of the opposite side of a leg of angle A divided by the measure of the hypotenuse of the leg of angle A. Okay, so notice that we kind of are coding stuff. If you notice, they're color coded here. Opposite and hypotenuse are going to be important words here. All right, so that's everything. Everything else is the same except for those 2 key words. So we're going to rewrite it so that we don't have to write the measure of opposite leg of angle A. Okay, shorten it down some more. What you'll see is the sine of A is equal to the opposite divided by the hypotenuse. Okay, abbreviate as much as you can so you don't have to write an essay in math. Okay, sine was opposite, purple. Cosine was green, adjacent. And then tangent was a combination of the last 2. So, sine of B. So Bob Barker's up here. And I want to find the opposite and the hypotenuse length. Opposite of Bob Barker's how much? 3. So I'm going to put 3 as the value of the opposite side. That's how long it is. And then the hypotenuse is here. How long is the hypotenuse? 5. Okay, so 3 over 5. Found my value for that. Sine of B is 3 over 5. Now we're going to find cosine and tangent. Cosine of B, now it's different. It's adjacent over hypotenuse. I'm going to go adjacent, which is 4. Hypotenuse is still 5. Hypotenuse, so we get 4 over 5. And last, the tangent, opposite over adjacent. We go opposite, 3 over adjacent, 4. Perspective for Bob Barker is he's going to jump off, but the kangaroo is going to jump up. Okay, so the perspective is changing. All right, that's why if you notice, if you look at the picture, why is adjacent over here, but on the orange one, the adjacent's down here? What's the deal? Why is there a difference? I thought this was adjacent and this was opposite. Well, it's with respect to the angle, the person that your perspective, where you're standing. We started with the rockets. Again, we were sitting, we had people sitting here, right? And the target was on the board, spot 3. And so here's our right triangle. We want to find out what was the best angle. Let's call it A. Actually, let's call it M for Maria because
Yeah. Okay. Maria's the target.
Yeah.
So Maria's about 3 meters from the board, from where she was sitting. And she was about 1 meter high, okay, from here. Given the level of the desk to the bullseye, it's about 1 meter.
Okay, so now we want to find out what was the best angle that she had to make sure she had her rocket launcher, so that way she could win or hit the target.
So again, looking at sine, cosine, and tangent, the only values that we know up there are adjacent and opposite. So which one would you use? Tangent. We can't use sine and cosine because we don't know the length of the hypotenuse. We could find it using Pythagorean theorem, but let's just, since we're talking about sine, cosine, and tangent, let's just use the tangent, and then equals opposite.
Opposite. Why is that opposite? Why is that opposite? Because she's looking right here, right? Does it make to be opposite? It's in the opposite direction, so this is opposite. And then why is this adjacent? Because it's next to it. And how do you know it's next to it? Well, here's the table. Isn't she next to the table?
Okay, so we have 1/3. Now to do this, we need to take the tangent inverse of both sides, and what that is, it's like a reciprocal.
Okay. So now, to end this lesson, or to kind of finish this problem here, I went ahead and just ignored we canceled out the meters and the meters, okay? And so now we've got to find the measure of angle M, Maria's angle. So we're going to have to do what we call an inverse. Okay, so we're going to do the measure of the degree of Maria was tangent inverse of 1/3.
And tangent inverses, kids can't really do that in their head, especially if you have a fraction like this. You would need a calculator, and you would show them how to use it on the calculator, but they would have to use it tangent and cosine and sine buttons. So I punched it in, and I would show them how to do it. So the value we got was 18.43, so it'll be 18.43 degrees at that angle.
Okay, so Maria had to have her rocket at an 18.43 degree angle in order to hit the target.
So we would throw in some more vocab here. What are degrees? What's an angle? We would discuss that and move on to the next lesson the following day.